Hi there, fellow learners. Are you ready to dive into the fascinating world of compound types in C++? In this exciting video, we'll unravel the mysteries of compound types, breaking down references, pointers, and everything in between. So grab your favorite drink, get comfy, and let's get started. Imagine you have a type that's defined in terms of another type. Well, that's what we call a compound type. C++ has some cool ones, references and pointers. Let's break it down. Let's take a peek at references. A reference is an alternate name for an object. Think of it like a nickname for your favorite pet. You define it with an ampersand symbol followed by a variable name. Check this out. Let me define an integer variable, call it original value. Give it an initial value of 45, and let's define a reference to this variable. Let's print out the value of this variable and this reference. And then let's change the value of original value through the reference. And then let's print them again. Let's build and run. The ampersand symbol before the reference value indicates that the reference value is a reference to an integer, and it is bound to the original value. It's like giving your pet a fun nickname. We then use the stdcout to display both the original value and the reference value. You notice they have the same value because the alias reference refers to the same object. When we change the value of reference value, it's like giving your pet a new favorite treat. But guess what? Your pet's name hasn't changed. Only their preferences did. Similarly, the value of original value has changed when we modify the alias value. Remember, when we define a reference, instead of copying the initializer value, we bind the reference to its initializer. Once initialized, a reference remains bound to its initial object. Therefore, there is no way to rebind a reference to refer to different object. Remember, references are not objects themselves. They are just another name for an existing object. Once bound, a reference stays that way. So, we must initialize a reference when we define them. If I try to create a reference without initialization, I will get an error. You see, references must be initialized. Now, let's talk about pointers. Pointers are like tour guides that point to other types. Unlike references, they are their own objects, so you can point them at different things. Let me show you how we can define and use pointers. Here, I'm going to define an integer variable with an initial value of 42. Then I will create an uninitialized pointer. Then I'm going to assign the address of value in the memory to the pointer. To get the address of a variable, we use the address of operator, which is nothing but ampersand. So pointer equals to address of value. Then let's print out the values of the this variable and the pointer. To access the value of a pointer, we need to dereference it. In order to do that, we use the asterisk operator to dereference a pointer. Then I can update the value of this variable through the pointer. To do that, I need to dereference the pointer because the pointer contains the address of value. So I dereference it. I assign the value of 100, and then the value of this variable is updated to 100. To check that, let's print the value again. Let's build and run. In this example, we declare an uninitialized pointer named PTR that can point to an integer. We then assign the address of an integer variable value to pointer. By dereferencing pointer using the asterisk operator, we access the value stored in the memory location pointed to by PTR. We can modify the value indirectly through the pointer, as demonstrated here. So, as you noticed, you define a pointer using an asterisk, and guess what? Pointers can point to other pointers too. A pointer to a pointer? That's like a treasure map to a treasure map. Let me demonstrate the pointer to a pointer in an example. Let me create an integer variable called num with initial value of 42. Then let me create a pointer to an integer, call it ptr1, and initialize it with the address of num. And let me create a pointer to a pointer, call it ptr2, and give it the address of ptr1. Let's print out the value of num by using this variable ptr1 and ptr2. use the dereference. I use the dereference operator to dereference it. Let me duplicate this line and modify it. So because ptr2 is a pointer to a pointer, I need to use the dereferencing operator twice. Let's build and run. Here we introduced a pointer to pointer scenario. ptr1 is a pointer to an integer and ptr2 is a pointer to an integer. By following the chain of pointers, we can access the value stored in num using pointer2, like this way. Okay, let's tackle the big question. How do pointers and references differ? A reference is locked to its initial object, but a pointer, it can change. You can assign a pointer to different objects. You can also define a reference to a pointer. With a reference to a pointer, you are making an alias for a pointer. Changing the reference changes where the pointer points. It's like having a remote control for your tour guide. Change the channel, change the destination. Let me clarify this in an example. Okay, here I have a variable called x with the value of 10 and a pointer called ptr which is pointing to x. I can define a reference to this pointer like this. So you need to read this from right to left. This is a reference to a pointer, of type int. We can update the value of x through the reference to this pointer. So if I dereference the ref to pointer, note that this ref to pointer it's like an alias for ptr. And now if I print out the value of x, we should see 12. In this example, we had an integer variable with a value of 10. We then created a pointer ptr that points to the memory location of x. After that, we declared a reference called reference to pointer, that is a reference to a pointer ptr. When we modify the value through the reference to pointer, it indirectly changes the value of x because the pointer ptr is pointing to x. There you have it, fellow learners. Compound types, references, and pointers, all in a nutshell. You are now armed with the knowledge to create intricate data structures and unlock new programming possibilities. Thanks for joining me on this learning adventure. If you found this video helpful, don't forget to hit that like button, subscribe for more exciting content, and ring that notification bell so you never miss an update. Happy coding!